So welcome back friends, welcome back in another video tutorial from microbiology with Antigenic. So today we are going to discuss about a phenomenon of virus that is a major headache of scientists and vaccine developers to protect us and to prevent the viral infection. Okay, so this phenomenon is known as antigenic drift. Okay, so what is antigenic drift? Antigenic drift is nothing but creation of new substrain of virus due to a small mutation in their surface receptors. Okay, so remember, for entering inside the host cell, virus first need to interact with the surface receptor present on the host cell by their surface receptors, right? So after that they will perform endocytosis or anything to enter inside the virus, to enter inside the host cell. Okay, so our host cell possess immune system that have the ability to make antibody against that virus, and also it provide us protection against the virus whenever that virus will going to infect us again. Okay, so how they do this? So remember, first of all, suppose this is the surface receptor for host cell and this is the surface receptor for our virus. Okay, so they interact and via receptor mediated endocytosis. Just take as an example, there are various type of mechanism of entry we are not going to discuss. The virus successfully enters inside the host cell. Okay, now the host cell will activate its immune system, because whenever there is a foreign antigen inside our host cell will activate its immune system and develops antibody against them. Okay, so and the specific feature of antibody is not only antibody is developed to provide protection against that particular pathogen for now, okay, but they also register that kind of antibody for future protection. Okay, that means whenever that virus again going to infect us, they will be destroyed immediately, because because host already have registered a particular type of antibody for them, so they will use that antibody and simply neutralize them. So next time virus cannot infect us, okay, or infect or can infect but immediately destroyed or neutralized. Okay, and remember one thing, the antibodies that are effective against virus infection are called as neutralizing antibodies. Why neutralizing antibodies? Because they simply interact with the surface receptor of virus and prevent their entry. Okay, so that is why they neutralizes them. Now, so what is the utility of that antigenic drift for in terms of virus? So remember, suppose it is a virus, and remember one thing, that antigenic drift is commonly observed in case of influenza virus. Okay, and the surface receptor that are present on the surface of influenza virus are hemagglutinin and neuraminidase. Okay, so suppose this is a influenza virus and these are the spikes or surface receptor of them. So these are hemagglutinin, because hemagglutinin play important role for by interacting with the host and facilitate viral entry. Okay, so suppose this virus has infected a person. Okay, so person's immune system produces antibody against that kind of hemagglutinin. Okay, and registered also as a memory for future protection. Okay, but after that virus have undergone a small mutation. Okay, and this small mutation leads to the change in hemagglutinin surface receptor. Okay, so what, and there is a formation of new substrain of virus with new type of hemagglutinin. So as a result, now when this virus will going to interact with the same person that it have developed earlier, it have infected earlier, now this is the immune antibody developed by the immune system of that person can protect the person from that virus. The answer is no, because the antibody that the person have developed against the hemagglutinin was specifically for the that structure, okay, that triangle structure. Okay, but now the hemagglutinin structure is quite spherical, or you can say circular. Okay, so how they can, those antibody can protect us from that kind of hemagglutinin containing influenza virus? So as a result, our immune system cannot provide immediate protection from them, so they will infect again us, unfortunately, and our immune system again have to fight against those influenza virus from the beginning. Okay, so that is the worst thing of antigenic drift. Okay, so and that is also the reason why scientists have to develop influenza vaccine in regular interval. Okay, there is no one and complete vaccination, because this antigenic drift occur in within every 2 to 3 years. Okay, so as a result, the surface structure changes rapidly. So the antibody, the vaccine that we have developed for that kind of hemagglutinin containing influenza virus cannot, there is no guarantee that they will protect us after 2 to 3 years, because during that time influenza virus can make a small mutation and leads to the formation of that kind of virus. Okay, with a completely new antibody. So that is the concept of antigenic drift. Okay, so remember, antigenic drift will cause small mutation that will produce new substrain. Remember one thing, there is no generation of new virus. Okay, there is just little change in the hemagglutinin or neuraminidase or surface receptor, more generally speaking. Okay, in the next video we are going to discuss about antigenic shift, where there will be a generation of new virus. I am going to discuss about that also. Now let's see about their mechanism. So let's see that picture first. So there is a person A who possessing a surface receptor that hemagglutinin will interact. Okay, but our antibodies recognize them and neutralize it, and as a result, person A is protected for now. Suppose now there is another person okay, that is person B, in which virus successfully infects, because for person B this is the first exposure of that particular virus, and during their replication, transcription and translation, remember one thing, is outside the host system or outside any living material, virus is inert, right? So virus have to have to insert or have to enter inside any living entity for their survival. Okay, so in person B, during their replication, transcription and translation, suppose there is a mutation occur. Remember one thing, in case of influenza virus, the RNA polymerase we are using, right? And RNA polymerase do not have any kind of proofreading activity. So there can be a incorporation of erroneous base which they cannot repair. As a result, there will be a mutation, and this mutated genome will be eventually packaged. And not only that, if this mutated base containing genome codes for hemagglutinin, so there will be a change in hemagglutinin construction. Okay, so as a result, there will be new substrain of virus with new hemagglutinin. Okay, so now when this new hemagglutinin will going to interact with person A's surface receptor, can antibody that was previously registered for that particular virus can protect us? The answer is no, that antibodies cannot protect us, and as a result, hemagglutinin can easily interact with the surface receptor and facilitate the entry of virus in the host cell. So that is what antigenic drift is. So mechanism is, as I have mentioned in that diagram, that addition of aron nucleotide by RNA polymerase, as a result it produces different substrate with different hemagglutinin. Okay, so remember, hemagglutinin is antigenic drift is gradual and sequential change in antigenic structure. It is occurred at regular interval, and if the accumulation of mutation, that is a kind of definition that you can use for writing antigenic drift in your exam paper. Remember one thing, that antigenic drift occur in every 2 to 3 years. Okay, so that is for today. We have discussed about antigenic drift. I will again come back with another video where we are going to discuss about antigenic shift, which is more dangerous situation than antigenic shift, because there will be generation of a new virus, and antigenic shift will ensure pandemic. Okay, so I hope this video will be helpful to you, and if it is, please hit the like button, share with your friends, and subscribe to my channel to get more videos like that. And thank you for listening to this class.